Hello all, my name is Sanjana. Today I'm going to teach you the physics Vernier scale calipers topic. To be honest, Vernier scale calipers and screw gauge topic are very difficult. But with clear explanation and precise practice, you can simplify the topics and ace the chapter. Now, to know about it, what is Vernier scale calipers? Let's talk about briefly. A vernier scale calipers is also known as the slide calipers. See here, the grey part is the vernier scale calipers and the white part is the main scale. Now on the main scale, the slide vernier scale calipers can also slide from to and fro. It is used to measure the length of a rod and diameter of a sphere and internal and external diameters of a hollow cylinder, the depth of a small beaker, etc. Now this vernier scale calipers, this tool can measure a sphere, a diameter of a sphere, a length of a hollow cylinder and the length of a rod. And to know the parts of the vernier scale calipers, let's know its description. A vernier scale calipers is shown in figure 1.3. It consists of a long and thin steel strip provided with a jaw 1. Now this white part is the steel strip. It is provided with jaw 1 at one end, and on the other strip a scale is graduated with the value of 1 division equal to 1 mm. This is the main scale, okay. Another small steel strip provided with jaw 2 at its end can slide over the main scale strip. This strip also has a scale graduated with 10 divisions on it, the scale of which is equal to 9 mm. It is the vernier scale. For more precise measurement, the vernier scale can also have 20, 25 or 50 divisions marked. So this is the vernier scale and that is the main scale. So on the main scale we have jaw 1 and on the vernier scale calipers we have jaw 2. Now the main scale has 1 mm division, whereas the vernier scale caliper, the whole length is equals to 9 mm, which is also considered as 1 mm. Now for precise measurement, you can also take as 20, 25 or 50 divisions. This already shows a precise measurement, but with 20, 25, 50 or more marked divisions, you can even more get the values very precisely. Now we came to know what is vernier scale calipers. Now let's know about the calculations. Now to calculate the measurements of the vernier scale calipers, you have to know about all these things. First is the least count, which is also very important, errors, and how to read. And what to read are main scale and vernier scale. Now coming to the least count, as you know, the measurement of the vernier scale is 1 mm. The least count formula is the value of one main scale division. Of course, we know that the value of one main scale division is 1 millimeters and by the total number of divisions of vernier scale calipers. Now you might be confused about the total number of divisions on the vernier scale is if I say 10 millimeters. Not millimeters, but as usual 10 divisions. So you might think, before I told it's 9 divisions, how come it's 10? The divisions are 9, the divisions are 10, but the length is 9. For example, you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, only 9. That's the difference. So you can take it as x and you can take it as n. So the value of main scale can also change, but in our ICSE textbook and to our knowledge for the students, we always take 1 mm value. So x value is 1 mm and the total number of divisions of vernier scale calipers is 10. So 1 mm by 10 is nothing but 0.01 centimeter or 0.1 millimeter. So for every calculation, as you as they give the main scale reading as 1 mm always. If they mention another value, another main scale division, then you have to calculate with the same formula. Or else if they don't give, you can always take it as 1 mm division. So always the least count is constant. You can most probably take it as centimeters. Now you came to know about the least count. Now what are errors? There are two types of errors, that is positive error and negative error. First we'll know about the positive error. To know about it more precisely, here is a clear picture. Now here you can see that the Vernier scale is this and the main scale is this. So the Vernier scale, the zero value is after the main scale zero value, which is considered as positive error. 0 is before the main scale 0, then it is considered as positive 0 error. Now to calculate what is the, this is known as the positive error, but what exact value is the positive error of? Now you can see what is coinciding. 0 is not, 1 is not, 2, 3, 4, 5, but 6 is coinciding with the main scale number 6. So now you take the 6 into the least count. So the 6 is coinciding, so 6 into the least count. Least count we already know it's 0.01 centimeters. So it is positive value 0.01 into 6, which is 0.06 centimeters. So now we got the positive value. Coming to the negative 0 error, you can see that the 0 is after the 0 of the main scale. Now it is considered as negative 0 error. Remember, if the 0 is before, it is known as the positive 0 error. If the 0 is after the main scale 0, it is known as the negative 0 error. Now same thing, 0 is not, 1 is not coinciding, 2, 3, 4, 5, but the 6 is coinciding. Since it is a negative value, you always get in negative values. 0.01 into 6, the least count into the value. You always get 0.06 in negative values. Now how to do the calculation? If it's the positive 0 error, it should be subtracted from the calculated value. If it's negative 0 error, it should be added to the calculated value. Excuse me for my bad handwriting. But if it's positive, it should be subtracted from the calculated value, but it's negative, it should be added to the calculated value. Now we came to know about the errors also. At the same time, we also came to know about the readings, how to calculate the coincidings and how to calculate the errors and all. Now we'll go into the main numerical of it. And another main thing is that if this is the main scale, if this is the main scale and this is the Vernier scale, and if the Vernier scale reading is between two numbers of the main scale, you have to take the least one. Not the biggest one, remember, but the least one of it. You have to be very careful with the Vernier scale readings. You can see here, this is the Vernier scale and this is the main scale. Now to calculate it, you can see that the 0, the starting point of Vernier scale calipers, is between these two things. Now to count it, it is 1, 2, 3, 4. As I told you, it's between, so you have to take the least one. So we take the 3.31. Next, what value is it coinciding with? Not this, not this, not this, not this, not this, but the sixth one. 5 and 6. The sixth one is coinciding with the sixth one. So they didn't give any zero values, zero errors I mean. So 3.3 is the starting main Vernier scale reading and the coinciding value is 6, but we have to multiply the coinciding value with the least count into 0.01, which we get 0.06. 3.3 into 0.06. So we get the answer as 3.36. So the length of the rod is 3.36 centimeters. Now in the next case, the fourth one, he already calculated the value as 1.4 meters with the positive error value as 0.02 centimeters. So since he already calculated it 1.4 millimeters, it's millimeters, and 0.02 positive 0 error. So now I have to subtract it from this. So as I told before, if it is positive value, you have to subtract from the main value. So it is 1.4 millimeters. If you convert this into centimeters for easy calculation, you get it as 1.04 centimeters minus 0.02 centimeters to 0.1. Now you can convert it back to millimeters because the focus value is on millimeters. So the answer will be 1.2 millimeters. So now you got the value after subtracting the positive 0 error value from the main value. This is how you calculate the numericals. So this is about the vernier scale calipers. Hope you understand, and if you like and understood this video, please share it with everyone. Let's meet with an interesting and enthusiastic topic in the next video. Bye bye.